remnants of another planet been found inside the Earth? Yes, these remnants are like two huge blobs, the size of continental rocks. Some scientists claim that they are remnants of an alien planet called Theia. Decades ago, scientists studying earthquakes found something under Africa and the Pacific Ocean. They discovered two massive rock chunks. Unlike Earth's, how did these rocks reach the Earth's core? At this depth, two huge continents were found with rocks unlike Earth's. Now the question was, how these huge stones would finally reach the core of the Earth. How? And then comes the claim of Caltech University's geophysicist Qian Yuan and his team. This is actually the remains of an alien planet, and they even have evidence to prove it. Now, ideally, when someone makes a claim with such confidence, they usually have valid evidence to back it up. But then just think about what this geophysicist could actually show as evidence, because that's the scientific methodology. Proving one's point, but then just think about what this geophysicist could actually show as evidence. I mean, the blobs they are referring to as alien are located almost to the Earth's core, as far as one has reached before, nor can anyone reach today. And the blobs that are being linked to the alien planet Theia are from a hypothetical planet that is said to have collided with Earth, been destroyed about 4.5 billion years ago. This means that the scientists might not have samples of that block, or of the hypothetical planet called Theia. I ask again, do we really believe in their research? How do blobs exist inside Earth? How were they discovered without destabilizing its rotation? How did scientists actually find out about its existence in the first place? Honestly, when working on topics like this, we often face misconceptions. Our goal is to clear these and present logical conclusions based on scientific evidence. We applied this approach here, starting from the basics. Scientists have these huge blocks, and we use the same thinking and methods, this topic as well. We started right from the basics, from the fundamentals. So first things first, scientists found these huge blocks. How did they actually find the scope near the Earth's core? How do they end up here? It's a very interesting story. Initially, the scientists didn't even aim to find huge blobs beneath the Earth. In fact, set out to find them. At that time, we were trying to solve a mystery. So the story begins. In the 1900s, on the Hawaiian Islands in the US, in just about 3 years, volcanoes have erupted. Now, normally, frequent volcanic eruptions only happen in places where two tectonic plates collide, meaning at the boundaries of tectonic plates. And that's because when two tectonic plates collide, the temperature and pressure inside the Earth start to rise. And the magma present there begins to come out as volcanoes. But you can see how far the Hawaiian Islands from their nearest tectonic plate boundary. The first question is about Mauna Loa and Kilauea in Hawaii, two of the world's most active volcanic hotspots. What is happening beneath the Hawaiian Islands that allows these volcanoes to exist so far from the tectonic boundary? Scientists mapped active volcanic regions and found connections leading to two places, Africa and the Pacific. To solve this mystery, when scientists created a map of all the active volcanic regions in the world, they found that all the connections lead to two places. One Africa, and the other one is Pesci, like literally. You look at this map of hotspots. The Hawaiian Islands are indeed in the Pacific, but these dry lava mountains known as the Siberian Traps and Deccan Traps, which you see in Russia and India, were also formed when Siberia was over the hotspot in Iceland, and India was over the hotspot in Reunion. So, these two plates have shifted from their positions. So, here we have two conclusions. First is that there is something beneath Africa and the Pacific Ocean. There is something that is giving rise to these hotspots. And secondly, it is possibly in the mantle. Even though the tectonic plates in the crust may move forward, these hotspots are not moving forward. So, what is that thing beneath Africa and the Pacific Ocean that is in the mantle? Well, the only way to find that out was somehow find a way to get into the mantle, because obviously just digging a straight hole isn't going to work. When Russia dug the Kola super deep borehole, they only managed to reach about 12 kilometers down. This means something like this happened. If I compare the surface of the Earth to the lines on my palm, the depressions in those lines are much deeper than what we've been able to dig so far. What I mean to say is that scientists needed better technology, and that's where some curious scientists from the US came into the picture. In fact, until the late 70s, the study of earthquakes was gaining quite a trend, the scientific community. So, some scientists in the US thought, why not penetrate the depths of the Earth through earthquakes? So, when an earthquake occurs, the entire Earth starts to vibrate. Some waves that emerge have the power to travel all the way through Earth. So in this situation, US scientists thought that by studying these waves, a map of the Earth's interiors could be created, and the entire responsibility for this mapping was taken on by MIT professor Kai-T Key, who discovered those alien blobs by measuring the speed of seismic waves generated by earthquakes. Seismic waves travel at different speeds through various mediums, creating a 2D map of Earth's interiors. Initially, scientists predicted wave speeds through the mantle. However, results showed a speed decrease beneath Africa and the Pacific, indicating another presence. Detailed investigation revealed 2 continent-sized structures resembling sand dunes beneath these regions. But then, the results from the experiment were completely different. While passing through the mantle beneath Africa and the Pacific region, the speed of these waves suddenly decreased, which means there was something else present in the mantle that caused the speed of those waves to change. Upon investigation, it was found that beneath Africa and the Pacific, there are 2 continent-sized structures. Scientists named the blobs beneath Africa and the Pacific. They then sought to connect hotspots and these blobs. After this YE discovery, scientists named the blob beneath Africa and the one beneath the Pacific. Then, they sought the connection between hotspots and alien blobs to check if blobs caused hotspots. In 1994, 2 geophysicists from Germany, U.R. Christensen and A.W. Hoffman, theorized, and this, just to explain the origin of these blobs, incident 1990. In 1994, 2 renowned geophysicists from Germany's Max Planck Institute, U.R. Christensen and A.W. Hoffman, presented a theory. According to them, 200 million years ago, when the Pangaea supercontinent was breaking apart, the Earth's oceanic crust began to sink beneath the continental crust due to its higher density, and eventually, it reached the mantle. After that, due to extreme temperature and pressure in the mantle, when it melted, the water particles present in it came into contact with the iron in the core and transformed into iron peroxide. Since the molecules of iron peroxide are denser than lava, they began to accumulate at the boundary between the core and the mantle, and over time, they formed 2 strange structures resembling blobs there. And because these blobs have been accumulating dense and heavy materials like iron peroxide, over time, for a long time, they eventually become overloaded and burst through the crust from time to time. Creating hotspots means that, until now, scientists knew that, number 1, most hotspots are in the Africa and Pacific region. Number 2, beneath these hotspots, there are 2 massive blobs. And number 3, these 2 blobs are the ones giving rise to the hotspots. Now, Christensen and Hoffman's theory explains blobs. She was able to tell how these blobs were formed. But this theory still had one answer missing. It couldn't explain why these blobs specifically formed beneath Africa and the Pacific. They could have formed elsewhere. Right. See, those days, many scientists pondered this. They believed they should find a theory, build on current knowledge, unaware it would lead to a dead end. Scientists thought he did not know that this very thought was going to lead him to a dead end very soon. Scientists thought connecting the hotspot to the blob was simple, but they struggled with linking blobs to Africa and the Pacific. Their theories focused on these elements, yet they couldn't connect them. This was mainly discussed in 2000. They just couldn't connect 3 elements. In 2021, a new theory emerged. Blobs are pieces of the alien planet Theia. It came everyone's attention. This theory claimed that the blobs are actually pieces of alien planet Theia, and reporting researchers claim that they have evidence for this. No, look, 1000. In 2021, geophysicist Qian Yuan and his team from Caltech University published a theory According to them, about 6.5 million years ago, Earth used to be much smaller than it is today. But then, a planet as big as Mars collides with Theia, and that massive impact causes the Earth to tilt on its axis. Number 2, a large piece of Theia breaks off and comes our moon. And number 3, remaining pieces get trapped inside the Earth. Actually, Yuan said that after the collision, Earth had completely melted. And because Theia's density was greater than that of Earth, and that's why the pieces sank down to the lower part of the Earth, meaning to our core. As for their current location, one alternate research suggests that to stabilize the Earth's new tilted rotation, these blobs must have lined up diametrically opposite each other, meaning they would be positioned in Africa and the Pacific. This is exactly what happens in a gyroscope. They balance out the rotation of that gyroscope by making different movements and statements. So this is the theory about Theia that was finally accepted, which solved the puzzle of hotspots and blobs. You can technically connect these three because it reveals where the blobs came from. Then it also reveals why they are located in Africa and the Pacific. And then, if we connect that with the theory of the oceanic crust, we can also find out why these hotspots are created. Meaning, we now have explanations for all those things we needed. Just one thing. What is the evidence? Proof. What do we have that supports the truth of this theory? Do we have any evidence that an alien planet like Theia ever existed? That Qian Yuan and his team claim that they have proof. They created a computer simulation to test their hypothesis, modeling a Mars-like planet named Theia with the mine's chemical composition. In the simulation, a collision with Earth resulted in a large part of Theia becoming the moon, as predicted. Earth melted from the collision, and Theia's remnants reached Earth's core boundary due to high density. So, a large part of Theia really became the moon in their simulation. Earth melted from that collision, and then the remaining pieces of Theia, due to their high density, even reached the boundary, Earth's core. Like the scene today we see Earth due to Yuvan's theory. That is because of Yuvan's theory. Now, finally, we have scientific answer for the origin of these blobs, and possibly it would be true. The problem? Now, unfortunately, we'll have to stick to this as just a theory. In this gen, to prove his claim about the remnants of Theia, Yuvan created a computer simulation, which Theia's chemical composition is essentially just gas work, because we still don't know the complete chemical composition of the moon. We only have proper data for the upper soil samples. So, in such a situation, I think there is a chance to create a simulated model of Theia from this incomplete data set. We can't completely dismiss the margin of error because that simulated model justifies the existence of those blobs to a significant extent. Yuan and his team are also well aware of the slow pace of their simulations. And that's why they are currently waiting to obtain lunar rock samples in NASA's Artemis mission. Eventually, they will try to match those samples with the blobs to prove whether the blobs are actually a part of Theia or not. And this brings us to the final question. Even if we get the lunar rock samples from Artemis, how will Yuvan compare the blobs hidden in our Earth's mantle with them? That's the question. It has personally excited me the most in today's entire video. Because Yuvan is going to compare the moon's rock samples with the blobs. This is a future project. This means there is no process mentioned anywhere about how they will do this. So far, it means we had to put our own gas here. So before I answer it myself, would you like to give it a try? Come on, if you have an answer, just drop it in the comments below. Trust me, answer lies in everything we've learned so far. And we too realized this later. So whatever answer you think is right, must have written it in the comment section below. Now, let's move on to the answer. You might remember, we talked about the oceanic crust theory, which explains the connection between hotspots and blogs. It clearly states here that because the blogs stay in one place, over time, the isotopes, meaning different variants, of elements present in those blogs start to concentrate. Then, the lava that comes out from the lava hotspots, piercing through the mantle, recycles these isotopes to form dry lava rocks. This means we don't need to dig down to the mantle to match the moon and block rocks. We just need to collect samples of dry lava rocks, like basalt rocks, from active hotspots like the Hawaiian Islands, and use them to identify the chemical composition of the blocks. Finally, we match them with the composition of moon rock samples. Today, simply put, it makes me think, is science really as hard and complicated as the world says? I mean, in my view, science is not just a subject, it's a way of thinking, an approach to solving problems, a perspective that makes us feel excited when we look at every challenging situation and every unsolved question. And once we find the answer, it feels like such an achievement. This is also about our personal growth, and we can use the same scientific approach in our lives to solve our life problems. And if you learned something new from this video, do give it a like, subscribe to the Get Supply Science channel, and turn on the bell notification so you don't miss any updates on our upcoming videos. See you next time. And until then, always stay curious and keep learning.